Good day, everybody. It is a pleasure to be here at the KOLOKIUM PENYELIDIKAN 2021. My name is Katherine and Francis, and I'm from Intan. And today I'll be presenting a little bit about my PhD study, which is entitled Experimental and Statistical Studies on Biodegradable and Non-Biodegradable Materials in the Electrochemical Industry. So before I proceed with my study proper, I would like to share with you all the 10 predictions for the next decade, which was actually a motivation for me to start this study. But then this report was published in 2021. I would like to draw your focus on the 4 last predictions. Number 7, autonomous vehicles, 8, green machines, 9, renewable energy, and finally, innovative companies. So where does Malaysia actually stand in the aspects of these 4 predictions? The green materials to actually produce an electrochemical device, we would also want to see how the acceptance of consumers are towards these electrochemical devices, and for that, we proceed with a survey of how much consumers are willing to pay. When I mention electrochemical industry, let me state a few examples of what electrochemical industry is about. A battery is a very good example of electrochemical device because it is a technological application which is important in storing energy. So once again, an example of electrochemical device is an energy storage device. Next, on the medical industry, we go to pacemakers. At one point in time, pacemakers were put in carts and were transported by the patient. But now it is so small, it is a microchip that it can actually be placed into the heart of a person. Next, we have the semiconductor technology, which produces cochlear implants for those people who are deaf. That is implanted and it is able to allow a deaf person to hear. So these are all the developments in the electrochemical industry that we have today. So how is this related in the Malaysian context? Why do I speak so much about electrochemical industry, but how is it related to the Malaysian context? As mentioned in the on the second slide on the predictions, when we speak about the National Automotive Policy, one of the things that are focused in our Malaysian National Automotive Policy is the focus on green energy and recyclability, whereby electrode materials for energy storage devices is one of the strategies. Next, we come to the 10-10 Framework for Science, Technology, Innovation and Economy, or also known as MySTIE, which is a framework to support the National Science, Technology and Innovation Policy of Malaysia. So in this policy, they also state the energy storage device as niche areas for socio-economic drivers. And how is that relevant to our study? This study focuses on green energy storage electrochemical devices. So what is the problem statement? I've already mentioned earlier that we have an issue with using dangerous chemicals in the electrochemical devices. So there is an option to use biodegradable materials as well. So in this study, we are going to use biodegradable and non-biodegradable polymers to become polymer electrolytes, whereby we do a comparison to investigate which is better in terms of efficiency. So once we obtain a biodegradable and non-biodegradable polymer electrolyte, we will then fabricate a device called electric double layer capacitors, which is an energy storage device, and we will investigate that particular device to see how its usage is going to be in a proper green machine. And then we want to know how much people are willing to pay and what decides for them on whether they are willing to pay for it or not. And what is the importance that we need to go green? We need to go green because the electrochemical devices contain toxic chemicals and harmful toxins such as nickel, lead, flame retardants and things like that. So this affects the health as well as the environment. So are there regulations against using these kind of toxic chemicals in electrochemical devices? Yes, there are. We have the directive by EU in 2005. We also have the ROHS, which is a directive which prohibits the usage of toxic chemicals in electrochemical devices. So the objectives of the study are to characterize and to prepare biodegradable, non-biodegradable polymer electrolytes, fabricate the device, test the device to see how efficient it is, and then investigate on people's willingness to accept it and pay for it. So these are the materials that have been used. Right. On the methodology part, I'll spend a little bit of time on this. Now, as has been mentioned, as you can see in the flow chart here, we have preparation of biodegradable tests. So to make them into conductors, we are going to add additives. In this case, we will be using ionic liquid and salt to provide the ions to actually make them into conductors from insulators. So we will obtain biodegradable polymer electrolyte films, and we will also obtain non-biodegradable polymer electrolyte films. For the biodegradable polymer electrolyte films, we will use polyvinyl alcohol, which is a biodegradable polymer, and for the non-biodegradable, we will use polymer methyl ethacrylate, investigating its ionic conductivity, investigating how it will last in an environment which has got high temperature or low temperature. We will then prepare the electrode, because electrochemical devices need both electrolyte as well as electrode. For example, in our batteries, we have electrolyte, electrode, ionic conduction that can conduct electricity. After that, we will fabricate the electric double layer capacitor. So from the biodegradable, we will take the highest conducting polymer electrolyte. From the non-biodegradable, we will obtain the highest conducting polymer electrolyte. We will fabricate the device, and we will test the device for its efficiency using cyclic voltammetry and galvanostatic charge discharge. That is the experimental, and then we will move on to the survey. So what is an electric double layer capacitor? It is an energy storage device. What is it used for? It can be used as memory backup for your handphones. It can be used as memory backup for your PCs. It can also be used as memory backup for, or as energy storage device for electric vehicles. So when it comes to sample preparation, this is basically the method that we use. Okay, and the end product is a freestanding polymer electrolyte film. It is very thin. It is just like a layer of plastic, but it is an electrical conductor. Yeah. So as I mentioned in the materials and methods, we actually add the polymer, the salt and ionic liquid in different ratios to investigate which conducts electricity the highest, and then we use that to fabricate the EDLC. Electrode preparation method is as stated in the slide. And this is what we call a supercapacitor. This is the EDLC that we fabricate. But of course, this is done in the lab, which is then put forward to be characterized or to be investigated using cyclic voltammetry and galvanostatic charge discharge. This is the theoretical framework for the survey part, whereby we have, through literature, we have come up with 5 different independent variables which we hypothesize would affect the consumers willing to pay for going green. This is the survey questionnaire which was distributed online. And the willingness to pay survey was actually done using the contingent valuation method. One thing I wish to stress here is, because this is not already a commercialized product, we need to use a contingent valuation method because it actually creates a hypothetical market. So this is what we did. Coming to our findings, this is the actual result that we obtained for the room temperature ionic conductivity. So when I say room temperature ionic conductivity, you can see that there are many dots there. So those actually are the results obtained for each of the configurations of the ratios that we used. So the highest conducting one from here was actually used to fabricate the EDLC. Next will be temperature-dependent ionic conductivity. The importance of doing temperature-dependent ionic conductivity is because it shows us which mechanism the ions in the polymer electrolyte uses to move around and conduct electricity. So that's this study. This is for PEMA. The previous one was for polyvinyl alcohol. So from the experimental data that we have obtained, we can clearly say, you can see ionic conductivity result, you see the specific capacitance results, and you also see the electrochemical potential window showing the stability, and it clearly shows us that the ionic conductivity, specific capacitance and electrochemical potential window shows improved values for the biodegradable polymer electrolyte system. As for the survey results, we can see that out of the 5 independent variables that we investigated upon, 2 were deemed to be significant, which is peer pressure as well as health and safety, and based on demographics, occupation and age of the respondent actually affected positively towards going green. One thing to note here will be the younger generation was more willing to pay for green handphones. When it comes to willingness to pay, we found that 90% of our respondents were willing to pay, in this case the green machine, or in other words the green handphone. And the reason the 10% were not willing to pay was because of the price factor. And how much, this was one of the main parts of the survey part of the study, how much were consumers willing to pay once for the green handphone. Yeah? So based on the survey that we conducted, we found that customers or consumers were willing to pay between 70 ringgit and 200 ringgit once. That means if the handphone cost 2,000, they were willing to pay between 2,070 to 2,200 for a green device. So the survey conclusions, as mentioned, from the 5 independent variables, we found that 2 variables actually affected the willingness to pay, which was health and safety as well as peer pressure. Peer pressure is pretty clear to us because the younger generation, they want to fit in. It is a trend that they want to fit in, they want to get more friends, so that can be one of the factors. But in addition to that, we need to note the point of health and safety, ladies and gentlemen. Malaysians are aware of the effect of using non-biodegradable products. They are aware of the effects not only for the environment, but also for their own health as well. We see lots of people who are willing to spend for health. So our results actually concur with that particular finding. I'm coming to the end of my presentation, and what is the take-home message that I have from this whole study that we have conducted? Now, the ideology for this research was actually to find a green replacement for the existing electrochemical devices that are manufactured using non-biodegradable or even dangerous synthetic chemicals. Why we do this? We want to be in line with the green revolution. We all know that the nation is being economically affected by the COVID-19 pandemic. Innovation needs to be embraced not just by the research community, but also by the government in the policies that we are actually enforcing, because we want it to be more economic oriented. So the research needs to be economically oriented. Science and technology needs to reprioritize and become impact driven and economically viable, not just for the satisfaction of the researcher, but for the benefit of the country. The National Science and Technology and Innovation Policy also focuses and has become the key enablers to ensure the advancement of science and technology is in line with the economic growth of the country. So, in addition to becoming a high-income nation, we also need to go green, and this will be done by once again falling back on our policies, as energy has been identified as one of the national niche areas to ensure sustainability and, of course, Malaysia to become globally competitive. The novelty of our research would contribute and drive towards the sustainable and inclusive growth towards a positive STIE application. We hope this research, the study that I have conducted, concurs with this vision and contributes a snippet of hope to the area of green technology and environmental sustainability towards the future. With that, I thank you.